You know, when you're scrolling through an app, do you ever stop and think, how did they actually build this? It's way more than just lines of code, right? There's got to be a plan, like a recipe. And in the software world, we call these recipes development models. Think of them as the blueprints that guide a team all the way from a tiny idea to that finished app on your screen. So let's jump in and check out the different kinds of blueprints they use. And really, that leads us to the big question for today. When you're building software, is it more like building a bridge? Or is it more like painting a masterpiece? Think about it. Is it this super precise engineering challenge where you plan every single detail before you even start? Or is it more of a creative journey, where the final picture kind of reveals itself along the way? Well, the answer, as we're about to find out, is it really depends on what you're building. All right, so first up, let's tackle that building a bridge idea. This is what we call the sequential approach. The philosophy here is simple. You create one massive, detailed master plan, and then you just execute it. Perfectly. One plan, one shot. No do-overs. And the absolute classic example of this is the waterfall model. I mean, the name pretty much says it all, right? You start at the top, and progress just flows steadily down, step by step, like a waterfall. And here's the crucial part. Just like a real waterfall, you can't go back up. You have to finish each phase 100% before you're even allowed to think about starting the next one. And you can see exactly how rigid those steps are. First, you gather all the requirements. Not some of them, all of them. Then, and only then, you create the entire design for the whole system. Once that's set in stone, you write all the code. And finally, way at the very end, you start testing everything. It is a strict one-way street. So what's the trade-off here? Well, this model is super simple to understand, and it's great if, and trust me, this is a huge if, you know exactly, down to the last detail, what you need to build from day one, and you're 100% sure nothing is ever going to change. But if you get a requirement wrong at the start, you won't find out until you're nearly at the finish line, and by then, fixing it is an absolute nightmare. It's incredibly expensive and difficult. Okay, so to deal with that whole testing at the end is scary problem, along came the V model. You can think of it as Waterfall's slightly more paranoid, cautious cousin. For every single development step you take down the left side of the V, you're already planning the matching testing step for the way back up on the right side. It's all about verifying and validating as you go. And this really gets to the heart of the V model. On the plus side, it's amazing for things where you absolutely cannot afford mistakes. We're talking medical devices, airplanes, that kind of stuff. Planning the testing early means you catch bugs much sooner. But it still has Waterfall's fatal flaw. It's incredibly rigid. If the customer changes their mind about a feature, the whole beautiful V structure can just shatter. It becomes a frozen block, and the paperwork alone is a huge headache. And that really hits on the fundamental problem, doesn't it? In the real world, you almost never know everything up front. The customer's needs change. Your competitor releases a new feature. The whole market shifts. That one plan, one shot idea starts to feel pretty risky. So what do you do then? Well, instead of taking that one giant shot, what if you built it in cycles? This is the whole idea behind the iterative and incremental approach. You break down one massive project into a bunch of smaller mini projects. This way, you can actually learn and adapt as you go. The iterative model is the perfect example of this. You start by building a really basic first draft version of the system. Then you show it to people, you get some feedback, and you use that to go into the next cycle, the next iteration, where you refine it and add a little more. It's kind of like sculpting, right? You start with a big block of clay, and with each pass, you slowly carve out more detail until the final form emerges. Now, the huge win here is obviously flexibility. You get a working version, even if it's a simple one, in front of users early on. And you can totally change direction based on what they tell you. But what's the catch? Well, it definitely makes managing the project more complex. You have to be really careful planning each of those cycles to make sure you don't just wander off course and never reach the final goal. Now, a close cousin to this is the incremental model. It's similar, but there's a really key difference. Here, the focus is on delivering usable, functional chunks of the final product. So let's go with a house analogy. First, you deliver a working kitchen. Then you deliver a working bathroom. Each delivery, or increment, adds a new, complete, and usable piece of the final house. The real beauty of this is that the customer gets something valuable they can start using right away. But, and this is a big but, it totally depends on having a solid architectural plan from the get-go. If you don't think through how all those separate pieces are going to connect in the end, trying to integrate them later can be an absolute mess. Okay, now for the heavyweight champion of this category, the spiral model.
This beast is designed for massive, complex, high-risk projects. Think NASA-level stuff. Its entire philosophy is built around one thing: risk management. With each loop of the spiral, the team's first job is to identify the single biggest thing that could go wrong, and then they build a prototype or a plan specifically to crush that risk before they move on.
Look, for those giant failure is not an option systems, its power is undeniable. But all of that constant risk analysis and prototyping, well, it gets really expensive really fast, and it requires seriously experienced managers to keep it on track. Honestly, for a simple little app, using the spiral model is like using a sledgehammer to crack a nut. It's just complete overkill.
So, we've covered the planners and the cyclers, but what if the world is just moving too fast? What if even planning in little cycles is too slow? What if the only thing that matters is reacting to what users want, right now, almost instantly?
And that brings us to our final group of models, the adaptive approach. Now we're getting way closer to that painting a masterpiece end of the spectrum. This is all about embracing change, making speed your top priority, and working in super tight feedback loops. And a key tool in this world is the prototyping model. The idea couldn't be simpler. Show, don't just tell. Instead of writing a 100-page document, you just quickly build a working mock-up, a prototype, and put it in front of users. This way you get real, hands-on feedback, and you can make sure you're actually building the right thing before you spend a ton of time and money.
It's an amazing way to explore ideas when things are a bit fuzzy. But there is a huge trap here. A user might see this working prototype and think, wow, they're almost done. They don't realize it's all held together with digital duct tape. And the real danger is that some of those quick and dirty shortcuts you took to build the prototype can accidentally end up becoming a permanent part of the final system.
And inside this whole adaptive world, you've got a couple of different flavors. On one hand, you have something like Rapid Application Development, or RAD. This is all about pure speed, using pre-built components almost like Legos to snap an application together as fast as you can. Then you have something like Extreme Programming, or XP. This is all about quality and intense collaboration, with practices like two programmers working on one computer to make sure every single line of code is as good as it can be.
So the big picture takeaway for these adaptive models is that they give you incredible speed and flexibility. I mean, they're super powerful, but that power definitely comes at a price. They absolutely require a team of highly skilled, disciplined developers, and they need constant communication and involvement from everyone, especially the customer.
Okay, so we've looked at all these different blueprints, the rigid ones, the cyclical ones, the super flexible ones. So which one is the best? And the answer is none of them, or all of them. The most important lesson here is that you have to pick the right tool for the right job.
And this table really breaks it down nicely. At the top, you've got your sequential models, like Waterfall. The whole idea is plan everything, then execute perfectly. This is what you use when your project's requirements are crystal clear and not going to change, like building that bridge. In the middle, you've got the iterative models. Here the idea is build, learn, and refine. This is for more complex projects where you expect things to evolve. And finally, at the bottom, you have the adaptive models. Their whole mantra is speed, feedback, and flexibility. This is your go-to when you're working in a really fast-moving environment and the requirements are fuzzy or changing all the time.
And that really leaves us with one final thought to chew on. Go ahead and pull out your phone. Think about the apps you use every single day. Which blueprint do you think they followed? What about your banking app, where security and stability are everything? And what about your favorite social media app, where it feels like there's a new feature every other week? Once you start looking, you'll see these blueprints are everywhere, shaping the digital world all around us.